afternoon, everyone. Welcome to the first of 4 sessions in the 2021 Winter Ops series from the Aviation Events Group. My name's Ian Witter, and over the next 90 minutes, we'll be focusing on GRF and runway surface condition management. You'll see to the right of the screen that you're able to communicate with other delegates and speakers in the stage and the event chat areas. Please say hello, and we welcome your comments at any point during the presentations. If you have any questions, please put those there. I'll be keeping a note of those, and we'll put those to panel members at the very end of the session after each has spoken, so when we've finished all the presentations. Firstly, let me introduce briefly the other speakers. The other 4 panelists are Paul Adamson from ICAO, Daniel Hultin from SYS-ASFT, Vasileios Stefanioros from EASA, the European Aviation Safety Agency, and Will Sutherland from Halifax Stanfield Airport. So firstly, a little bit about me, and then I'll say some introductory words and we'll get started. With 34 years experience in airside ops management, I've led a team from a number of UK airports. I've been chairman and a member of various committees and working groups in ICAO, in Eurocontrol, Airports Council International, EASA, and the UK CAA. I'm a qualified airfield safety auditor and author of various industry best practice documents. The reason I'm here today chairing this session is that I was a moderator at the ICAO Global Reporting Format Workshop held in Montreal in 2019 as a result of representing airports in the ICAO Friction Task Force for about 10 years. So let me set the scene to get things started as to why we're all here. Runway excursions have been identified as a top risk for aviation by ICAO and a number of member states over many years. Before 2010, a number of authorities had prevented the direct reporting of CFME numbers to aircrew in conditions of contaminated runways. And also back in those days, many states had their own historical methods of dealing with contaminated runway friction. Indeed, there were different methods used in Canada, in Russia, in the US, across some European countries. It was quite different from place to place. And so much so that in the FTF, there was a long-haul cargo pilot who made the comment that as he flew around the world, he needed a library in the cockpit containing the friction procedures for each country that he flew to. The issue that was being faced was how to bring together the aircraft performance calculations for safe landings and takeoffs with the contaminated runway conditions to enable safe decisions to be made. And so a key part of the FTF, the Friction Task Force, and indeed the Talpa ARC that I'll mention later, was indeed the participation of Boeing and Airbus. After the Chicago Midway accident in 2005 and the NTSB review, the Talpa ARC group in the US looked at the problem and proposed a system and began trials. Talpa ARC is the Takeoff and Landing Performance Assessment Aviation Rulemaking Committee, quite a title. This work subsequently formed the basis of the GRF and first devised the runway condition codes and the matrix. ICAO formed the Friction Task Force sometime before 2010, I think around 2008, which included a wide participation of regulators, of airports, ACI, IATA, airlines, ATC organizations, and pilots groups. So it was quite a wide-ranging group. And indeed, it's fair to say it's one of the biggest changes that I think ICAO have made. It touches many annexes, many documents, and it really is one of the more significant changes that's been made over recent years. Indeed, in those discussions in the early days, it was agreed in the Friction Task Force that a new or a single common method was needed. And the laws of physics are the same everywhere, but each state preferred their own method to be adopted. Moving forward a little time-wise, the ICAO GRF was published actually back in 2016 in the ICAO Panzeraerodromes document. And in addition, since then, there is an ICAO circular and an aeroplane performance manual also published in the ICAO documents. Presently, ICAO are working on guidance for states for the implementation to be ready in November this year. Implementation was proposed for 2020, but was postponed for a year due to the pandemic, and quite rightly so in my view. The EASA have taken the global reporting format into the European aerodrome rules, and I'm sure Vasileios will say more about that later. So to wrap up my introduction, I suggest, if not already completed, some detailed consideration needs to be given now to the practical implementation ahead of the November deadline, and be that at a national level, an airport level, an airline operator level, and tease through all the things, including ATC communications, use of ATIS, AIS, and the new SNOWTAM. So there's quite a few practical aspects to get one's head around before the November deadline for ICAO, and indeed the August deadline for, I think, EASA and Canada. So, okay, that's enough of an introduction from me. We'll proceed to hear from the four speakers. I'll introduce the speakers, and then each will present in turn. Please submit any questions you have as they occur to you, and we'll have a Q&A session, as I say, after the four presentations. So first up is Paul Adamson from ICAO. Paul joined ICAO in 2016 on secondment from Eurocontrol, where his last position was head of airports for the network manager. At ICAO, he's responsible for coordinating the GRF implementation and is the focal point there for runway safety. Previous to that, he was responsible for runway safety and ASMGCS activities in Eurocontrol. Paul spent 4 years on secondment to the CESAR joint undertaking, where he was the program manager for their airports-related activities. Paul's background is an air traffic controller, and he also has an MSc in airport planning. So Paul, over to you for your presentation about ICAO. Thank you.
Okay, thank you, Ian. So let me just try and share my screen. Okay, good. So good morning, everybody. As Ian said, my name is Paul Adamson from ICAO, where one of the things I'm looking at after is the global reporting format and its rollout globally. So I'd just like to say a few words of introduction on the global reporting format, the work that's been done in ICAO, and some of the challenges that we're facing as we run up to the November date, and how we're trying to mitigate those challenges. We use the tagline, be aware, get ready, and I think I should have put 2 exclamation marks after each of those phrases, because we're really getting up to the deadline now and people really need to be aware and start to get ready. So as an introduction, runway safety is really a global safety priority. It remains a global safety priority. Runway excursions are one of the highest risk categories within that, within those priorities. And of course, poor braking action is a top contributing factor. Now, to back that up, I've been looking at some of the data over the last few years, and I have noticed that since 2016, the number of accidents has been creeping up. We had globally, according to ICAO's recent safety report, 75 accidents in 2016, and that crept up to 114 in 2019, which of course you might expect to see as the traffic grows, but it's still a disappointment because we want to keep the numbers down. And if also, if you accept that around about 50% of accidents, as a rule of thumb, are runway safety related, and I think about half of those are normally runway excursions. The other half are related to hard landings and bird strikes and such like. So the situation has been slowly, I think, deteriorating, if I can use that term, over the last few years as the traffic grows. And you would expect then, as the traffic tails away in 2020, that the situation would maybe start to improve to a certain extent. But in fact, it hasn't. According to IATA's recently released safety report, the accident rate has gone up from 1.1 accidents per million flights to 1.7 in 2020, which I think is quite a significant increase. And if you accept that runway excursions and braking action form part of that global picture, then there is something that we still need to keep our eye on and keep moving forward on. So bearing in mind the big picture, ICAO has been working on the global reporting format, the GRF, since about 2008. We're looking for worldwide implementation from November 2021. As Ian mentioned, this date has been delayed from 2020. I think ICAO took a very correct and perhaps slightly courageous decision to delay the applicability date by 1 year. Not an easy task for an organisation like ICAO, but they listened to the states, they listened to industry, and they realised that we had a lot of challenges in front of us and we needed that extra year. And I think we've made good use of that year that's been given to us. So the date is now November 2021. Background, Ian alluded to some of this. So pre-2004, there were a couple of high profile accidents. Let's use that term. I think Midway was one of them, and I think I remember the Airbus in Toronto might have been another. But runway excursions and runway surface conditions really came to the fore in aviation prior to 2004. The FAA tackled this initially with the Talpa Arc, as Ian was talking about. We really needed something global. So in 2004, the runway friction topic was included in the panel work program. The panel at this time being the Aerodromes panel of ICAO. To kind of scope what needed to be done, in 2006, a questionnaire was sent out to member states and experts to try and identify what the scope of the problem was relating to surface friction characteristics. As a result of that survey, in 2008, the Friction Task Force was established, which was supported by expert groups and also by other panels. As Ian said, the global reporting format, runway surface conditions, touches on many different aspects of aviation. So many different ICAO panels were somehow touched by this work, and you'll see that through the list of documents I'll show you later. The objective was to develop this globally harmonized methodology for runway surface condition assessment and reporting. And of course, we were lucky to have the work that had been done in the US previously, the Talpa Arc, to get the ball rolling. So the development of the SART, so I'd just like to show you this diagram, not for the purpose of explaining all the ICAO processes to you, but to explain that there's been buy-in, that the review has been very thorough, and in my view, we don't need to discuss it anymore. We just need to go on and deploy it. So the Friction Task Force was established in 2008 with 10 member states represented and 7 international organizations, so IATA, ACI, CANSO, perhaps Eurocontrol, and those type of organization. They did their work and they brought the results of that work a few years later to the Aerodrome Design and Operations Panel, previously the Aerodromes Panel, now changed name, where we have 17 member states and again 7 international organizations represented. So they reviewed the work, they accepted it and agreed to it. It was sent out as a state letter then in around about 2015. Where 59 of the 193 ICAO states responded and 6 international organizations as well. And that means that these states had comments, views, opinions on what had been proposed by the Aerodrome Panel and the Friction Task Force. Now that's a very thorough process because everybody gets the opportunity to comment on the proposal and have their comments taken on board or at least responded to through that state letter process. So once that process was completed, sometime after 2015 into 2016, the Air Navigation Commission, where we have 19 senior experts appointed by 19 member states, reviewed the proposal, amended through the state letter process, and agreed to it. And this is kind of the highest level, what I would call operational body that we have in aviation. And once that was approved, it went to the ICAO Council, which is the political decision-making body in ICAO, where we have 36 member states represented, and they agreed to it as well. So it was published in the ICAO documents thereafter in 2016, and we've had a few years to work on it towards implementation in 2021. So the point there is that the process has been very thorough. Everyone's had the chance to comment on it, all the states have, and a lot of people have formally agreed to it. So as I say now, we have something that is high quality and we need to get on and deploy. So what is the GRF? So I wouldn't profess to be the expert on the GRF. The real experts are in the Friction Task Force. But what I like about it is its simplicity. It's a standardized report and a common language that we should all understand around the world. So the cargo pilot that Ian mentioned the other day, earlier, he doesn't need to have that library. He just needs to have this one thing in his cockpit. The main elements of it are an assessment matrix, which you can see there on the right-hand side of the slide, called the RCAM. In that, you can find runway condition codes and associated descriptors of the surface conditions. So the idea is that you're out on the runway, and it really is a human observer-based methodology. So the trained experts, observers, assessors go onto the runway. They observe the runway, breaking it into thirds, and they allocate a runway condition code and a surface descriptor to each third of the runway, which is then put into a runway condition report, a standardized format, which is transmitted to air traffic control, who then make that known to the AIS services to transmit via SNOTAM and broadcast if necessary to flight crew on the frequency or put on the ATIS. So it's a very standardized, very simple process, very simple matrix, which is based upon human observation. So I think it's based upon an operational need. Ian alluded to that before. It's simple and it should be standardized because we've agreed to it. And through that, we will improve runway safety or aviation safety in general, and of course, situational awareness of flight crew as they come into airports. So that's the GRF in a nutshell. Two kind of subtleties within that simplicity. There are two scenarios. We're all familiar with winter operations and runway condition reporting winter operations, and I bet that pilot, most of the library that he had was relating to winter airports that have snow and ice conditions. However, many runway excursions occur on wet runways, and the GRF includes wet runways. So we have a simpler version of the matrix, which can be used by airports in tropical areas or areas that don't experience winter conditions. So a simpler version of the matrix, just dealing with wet conditions basically, that they can use. The challenge therein is the fact that the winter operations airports are used to doing some kind of assessment and publishing something, not the GRF, but their previous methodology. For the airports experiencing wet weather, the tropical airports, this is really something new. So there's an additional challenge of awareness and training and understanding to be addressed at those airports. So that leads me on to the challenges that we have. The main challenges are awareness, planning, training, time, and the need to harmonize. So I'll just run through those quickly just to say where we are and what we've been doing. So the awareness, that was a real challenge and perhaps remains a challenge. We started to address that back in 2019 with the global symposium that Ian very kindly moderated one of the sessions for. So I think that was quite a successful event. In those days, it was face-to-face. Everyone came to Montreal and we had a good turnout, very good discussions. And from that, we had some spin-off regional seminars. So we started to do those around the different ICAO regions. We ran about 10 face-to-face seminars around the globe. And since then, we've done about another 10 webinar type events around the globe as well. We continue to do those, and we will continue to run those right up until the November date. In fact, the next really interesting one is one for the Russian-speaking part of the European region, which takes place in May. That's cascading down into a number of state workshops. So states themselves are starting to do internal communications to their airports and industry. Industry are doing the same. We have ACI, IATA, and others also starting to run events for the specific sector of aviation that they represent. Other communications actions, this kind of events, articles and such like. We have a website, just Google GRF ICAO, it's at the top of the list, and you will find that as a nice repository of all the information. The address is also at the end of this presentation. And a really key thing is we're working through partnership here. So myself and ICAO, I'm not kind of some super manager dealing with the GRF and forcing everyone to implement. This is done through partnership, and we work together. All of the events, we support each other in the events, and it's really a global industry, states, aviation partnership, which is bringing this to implementation. The planning side, so in the States, that's underway, and in many regions, states have been encouraged to submit their plans to the ICAO regional office, just to encourage people to do their planning. So that's kind of underway. There are some areas where it's better than others, so there's more work to be done, but it is continuing. And we have a kind of a checklist that you see on the right-hand side of the screen, which states can refer to, which might help them get started with their own planning. And in fact, the milestones that are in that checklist we are using for reporting. So we're asking states to report to their regional office against the milestones in the checklist on the right-hand side. So the regional offices are taking a leading role in encouraging and supporting states and industry in their regions to implement. Of course, stakeholders, the airports, airport operators and ANSPs are heavily involved, and we engage with them through the standard organisations, and also through other aspects, through runway safety and encouraging runway safety teams where they might have a role in encouraging planning or supporting planning. And we start to do implementation monitoring, not for the purpose of punishing people or whatever, it's just to kind of see what the picture is, and to encourage peer encouragement, let's put it that way, to implement. And also to know that if your neighbouring state is doing quite well, they might be a good source of reference. You can maybe go to them and ask if they have any advice or best practices that might help you. Training, awareness is important. Training is perhaps even more so, and particularly challenging in the current crisis. To help that, in ICAO, we've worked with industry to develop a number of courses. We have one for airports developed with ACI, which can be accessed through the website. One for airlines developed with IATA, and one for ATC, which has just been released last week, which has been developed in cooperation with IATA and CANSO. So those courses are available as CBT courses. Just go to the website or the respective organisations, you will see them there. In addition to that, there are some classroom courses which aren't for airport operators, which aren't really used at the moment. But what we have done is with ACI, we're converting those into CBT courses and translating those into other languages. So Spanish, French and Russian versions of that classroom course will be available as well, because for airport operations staff, we don't always have the level 4 English, and perhaps something in your local language might help. Time, okay, we're running out of time. I'm perhaps running out of time myself now. So we need to start now, or you need to have started. The first thing is to appoint a state focal point, or if you're an airport or industry, know who your state focal point is. If you have any difficulties, talk to ICAO, in the first instance, the regional office. If not, you can always come to me. We need state, regional and local plans. That's underway, and quite encouragingly, ACI did a survey of their members a few weeks ago, and it showed that 70% of their membership are planning for the GRF, which I think is quite a good picture at this time, and hopefully that will grow to 100% over the coming weeks and months. Some states and some airport, or some states in particular, are doing shadow mode trials. I know that in some of the African states, they're doing a regional shadow mode trial in August of this year, which I think is quite an interesting activity. And of course, there are some industry focal points that you can turn to. Ian might be one of them. So there we go. Harmonisation, as always, this is a really big challenge, and that's what we're all about. That's why we work together. We do that through awareness, through planning, coordinating together. We have an informal coordination group where we talk to industry, through the training, doing the same training, and also addressing a number of implementation topics where people might tend to go astray. So ATIS is one of them, where people were looking for more guidance on how to formulate ATIS messages. So we've done something on that. The SNOTAM, the new SNOTAM, people were looking for guidance on that, and there is a document available to help you with the SNOTAM. Human observation, really important, and we're just starting to work with ACI to develop a little bit more guidance on how to do human observation. It probably seems quite obvious, but some additional guidance is needed, and we will provide that. The upgrade-downgrade procedure of the GRF, which is a kind of slight nuance of the GRF and an important aspect of it, is something that people need a bit of extra information on as well, so we'll start to work on that. And training compliance, so how we use the training to fulfill states' training requirements. So conclusions, GRF is really important for safety and efficiency, particularly now as we recover. We need confidence in aviation, we need runway safety, and the GRF is a very important contributor to that. It's approved and standardized, so we don't need to talk about it too much. We just really need to go on and do it. We can trust that it's been developed by a lot of skilled people and approved by many skilled people as well. The provisions are published. The training resources are available, so we need to start planning and implementation if you already haven't done so. And another important aspect, because we have this standardization, I think the GRF is something that's really applicable to SWIM, transmitting information through more modern means, and also looking towards the future. I think artificial intelligence might enable us to understand when and how runways are closed for snow clearance operations and how long they might be closed. And coming from the network manager, I kind of think that that might be the sort of development we see in the future, modeling the behavior of runways within a network. ICAO references, there are many of them there. It's a good list there for you. That illustrates the scope of the topic, how it touches everything from aircraft operations through to AIS. So there's a list there, so you can go and have a look at those through the ICAO website. I'll pile them all up there neatly for you so you can see. But no, that's all the ICAO annexes in one pile. That's not the GRS stuff. And there we go. That's all I have to say. Ian, I'm happy to take questions at the end, so I'll hand back to you and I'll stop sharing.
Okay, thanks, Paul. That was very illuminating overview of the work of ICAO. I see there's a poll running as well to ask participants how ready you think you'll be for the deadline. So please respond to those, and then we can. That'll be interesting to see what state of readiness is of the participants today. And if you have any questions, as I say, please put them in, and we'll deal with those at the end. So thank you, Paul. If we move on to the next speaker, Daniel Hultin. Daniel's worked in the aviation industry since 2011, where he joined ASFT Industries. He was tasked with the sales of runway friction testing equipment and runway weather information systems. He's continued to do this in the global marketplace ever since, both at ASFT Industries and then the merged company SYS-ASFT. Prior to joining ASFT, Daniel worked for 7 years in the global shipping conglomerate AP Moller Maersk in Copenhagen as a shipbroker and market analyst. Daniel holds a master's degree in business administration in technology management from Lund University in Sweden, and he is married with a daughter. Daniel, the floor is yours.
My name is Daniel Hultin, and my take on this might be a slightly different one because I come from the manufacturer of friction testing equipment. But here we go. So the GRF, it has been spoken about previously, but to sum it up, you are to land one of these. In this, without this happening. And the tool that you have at your disposal is essentially your eye. In a nutshell. Now, does the industry provide any tools? Yes. We, as a company, has developed a tool called SNAP. And what is that all about? The GRF says that you are to focus on contamination. So first of all, you are to assess contamination type. What is on the runway? Is it snow? Is it water? Or, God forbid, ice? Furthermore, you are to assess the contamination depth. This might be a little bit too deep to land in. You are to assess contamination depth with regards to snow, but also with regards to water, in particular standing water. You're also to assess contamination coverage. How big proportion of each third of the runway is covered with said contamination? 100%? 0%? And this was supposed to be showing something in between, but I think this would be regarded as 100% coverage as well. So, you're out on the runway observing. What tools can you have for this? Ta-da! We have developed an application that you run on an iPad called the SNAP. And in its bare form, it's a tool to input what you see, and you will get the GRF out of it, the runway condition code. But before we move into that, a few remarks. As I said, the GRF is you're supposed to observe what is on the runway. But this system is a multi-user system. So you can have several colleagues out on the runway or infrastructure observing what they see. And each member reports into the same system and they are connected with each other. So it means that you can have one person reporting at each third of the runway, for example, and the other colleagues will see what each one of them are reporting. And that's the basic idea of this system. However, it is only the duty manager who will make the final sign-off. But if you just look at the functionality, you have each third of the runway at the top. You are then to enter what kind of contamination do I see here at this third? For example, frost. You are to tell how big proportion of this third is covered with frost as a drop-down menu based on the rules of the GRF. And for some contamination types, the depth. How deep is the contamination, the thickness? And based on these simple inputs, runway condition codes will be generated by the system in the bottom of the section. However, the system enables you to upgrade or downgrade and tell why you made that choice. You also have a section for aprons and taxiways. You can go and look on a map how this translates into your infrastructure viewed as a map. And in this case, this map is from Berlin that we have worked together with in this project. And in this case, of course, this is a very colorful map that I've generated. I don't expect to see this in real life, these kind of conditions, but it's just to illustrate how we can view the conditions on a map. You go back to reporting view. You can then preview. This is how the snowstorm will look before you send it. And then you can just press send. And this can be done either as an email attachment, or we can hook it up directly to automated systems, such as Eurocontrol. Information sources. So, as said before, the main source of information is your eye. What do we observe out on the runway? However, there are possible alternative sources of information when you're going to assess the conditions on the runway. Here on this picture, I have a very happy managing director out on the runway in Cologne, where you have runway sensors. Sensors that measure the contamination type and depth out on the runway. Those could be a possible source of information when generating the GRF. You have optical mobile systems, and in this case, I would argue that the greatest benefit is their ability to assess contamination coverage, produce that percentage figure. This big proportion of the third is covered by said contamination. But remember, the eye is the principal source of information. The automated systems are the future sources of information. And even though we manufacture and supply these kind of systems, I would argue that start by learning the GRF as its original intention. Do it by observations with your eye. And I would like to make the comparison. You can buy a fancy Tesla today that it's almost self-driving. But you can't go out and use this fully automated system without going to driving school, taking a driver's exam, and learning how to drive an old-fashioned stick-shift car. And I would say the same logic applies here. Learn to operate with the GRF using observations. Thereafter, go on to using technology. Then we have the question of comparative information. What is this? Well, this is information that you're not using to generate the GRF, but can in some cases be used for other purposes in this context. For example, braking data from aircrafts. We have a cooperation with Navblue, an Airbus company, to enable the presentation of braking data from A320 family aircrafts in the application. We are manufacturers of friction testers. As I said previously, some countries do not like them at all. Some countries do like them. And in that case, you could view the data. The braking action data from the aircrafts is for peace of mind and documentation, whereas the braking data from a friction tester is solely for peace of mind, and this is also depending on local legislation, if you are allowed to view that information. So it's not a standard feature. This is not maybe in winter conditions, but I would like to draw some attention to a factor. I don't know if it has been looked into, but here you have a runway excursion, and here comes the investigating team. And I chose this picture on intent. If you look at the tail wing, see who the carrier is. When something like this happened, questions will be asked. Who's responsible? What can you document in this situation? And ultimately, who pays the bill? In that case, this is where the braking data from aircrafts come into play. Because I think it would be rather nice to have the braking data from aircrafts documented next to a GRF in the systems, basically verifying what you have observed, and to be able to present that in relationship to your GRF. So saying that we have information that we made this assessment, not only based on what did we observe, but actually what did the landing aircraft's braking system tell us. You don't form the GRF based on that, but it's there in the background. And finally, I'm going to throw something out here. My concern is what will happen with insurance premiums at airports once the insurance companies finds out that we are going to land these fancy aircrafts using this as a main tool of information. Thank you.
Okay, thank you, Daniel. Some interesting thoughts there, and yeah, a good update certainly on the technology. So yes, very good. Thank you. We move on to the next speaker, Vasileios Stefanioros from the European Aviation Safety Agency. Vasileios started his aviation career in the Hellenic CAA in 1995, working at Kos Airport, and later in the Airport Division and Flight Standards Division. In 1999, he joined Athens Airport as head of airside ops, and in 2005 was appointed head of the Aviation Safety Management System.
Hi to.
Since January 2011, he's worked at EASA as EASA's Senior Regulations Officer Aerodromes. His main area of expertise is aerodrome operations. Vasileios is a regular member of the ICAO Friction Task Force and has been involved in the implementation of the GRF throughout the EU. Vasileios, over to you.
Thank you very much, Ian. I think you can see my screen. Also, I wish to thank the organizers for the invitation to EASA to present in this very interesting event. So I'm going to tell you how we are going to implement the GRF in the EU member states. And I will describe you also the process and some differences we have with ICAO. So just give me a second. So in my presentation, I will talk about the regulatory process and then the rules that we have for the aerodromes, ATM, ANS, and AIS, as well as for air operations and how we use the performance data and the implementation. And starting from the regulatory process, I just want to repeat what Paul said, that and Ian, that runway excursions are one of the biggest issues we face in aviation. And following an analysis, one of the contributing factors is the runway surface condition and the way it is assessed and reported. And this is also substantiated by different data. So the graph you see represent the runway excursion data we have in EU member states. And on the right-hand graph, you see the number of accidents and incidents the last years. Well, we have data until 2017, and we had this data because by that time we started developing the regulations, are the runway excursions at EU member states where where the runway surface condition was one of the top contributing factors. So, as an agency, we are receiving a lot of safety recommendations, and many of them refer to runway surface condition. And I want to say a little bit on a study that has been conducted by the Norwegian accident investigation body, where they have analyzed quite a number of runway excursions, where the data revealed that the runway surface conditions was a contributing factor, and the main issue was the way the surface conditions have been assessed and reported. Everybody knows about the accident at Chicago Midway. I think it was back in 2005, where NTSB issued a safety recommendation to FAA that they have to do something. So we had the TALPA ARC back in 2009, which was the initiative of FAA. And then we had the first ARCAM, which has been used for assessing and reporting the runway surface conditions. And then this has been taken over by ICAO, as Paul said, and the Friction Task Force developed the global reporting format, which will apply by 2021. And in EU, EASA took over the ICAO proposal and included this in the EU regulatory framework. So the GRF touches different domains. So it touches air operations and the initial airworthiness, aerodromes, ATM, AIS, and MET. So it was a multidisciplinary task, and we have to approach it from all angles. So we established four different rule-making tasks, which you see on the screen. It was one dealing with air operations and initial airworthiness, the other one for aerodromes, and the last one for ATM, ANS, and AIS. And we followed when we were preparing the rules, we had in mind some very basic principles. First of all, we had to follow ICAO provisions as close as possible because it's GRF. G means global, so we cannot deviate too much from ICAO because we would have undermined global application. On the other hand, we need to take into consideration how the rules are structured in EU. So we had to find the right balance between implementing rules, is what we call hard law, and it's not very easy to deviate from this, acceptable means of compliance and guidance material. So we and I think Ian was part of this rulemaking group. So we reviewed and analyzed every ICAO provision, and which was related to GRF. And we tried to keep the basic principles of the GRF at rule level. So that was the main reason in order to avoid and to prohibit deviations from the stage. Now, things that were procedural, and our concern was to have we were focused on outcome. We decided to give some flexibility in order to adjust to local conditions, to the workforce of the aerodrome, the availability of different means to conduct the assessment. So the procedural things will have been placed into acceptable means of compliance. And because this is a new method, we provided a lot of guidance material. You know that not all aerodromes in the world have access to ICAO documentation and to different documentation from various sources. So we tried to combine all this information and provide this to the industry. So it's not only implementing the method, but they also have to understand the method. So the outcome of the rulemaking tasks were three different opinions which addressed the different domains, and we are very happy because last week we completed the whole package by publishing the last decisions containing AMC and guidance material for air operations. Now, on the aerodromes, well, as I said, we try to keep to stay as close as possible to ICAO. And what are the main differences? Well, is first of all, the publication of friction measurements. We do not allow this. And I'm repeating this, that we do not forbid the use of CFMEs. It's the use of CFMEs is an integral part of the process, but the values are not published because, first of all, we do not have performance standards for this type of equipment as EU. So there might be standards elsewhere, but not in EU. And of course, friction values cannot be correlated with aeroplane performance. But friction measurements can be used in a comparative way. So to give you an indication on the condition of your runway. This is how we are planning to use the CFMEs for the time being. And it's in our plans to develop standards for this type of equipment, but at a later stage. The other thing is that we have included two new terms for describing runway surface conditions. The first one is a specially prepared winter runway. You will not find it in other parts of the world. And the reason behind was that in some northern European countries, well, we have quite very heavy winter and very low temperatures. And in practice, the runways are covered with snow and ice all year, well, during the whole winter period. And because these runways are receiving a specific treatment, we are talking about a new surface. And this is not foreseen in ICAO. And well, we have developed a process to accept this type of surfaces which they have a runway condition code greater than 3. So normally they will have a runway condition code of 4, but this is something that has to be approved by the authority under a specific and very robust approval process. The other thing is the introduction of the slippery wet. And if you are familiar with ARCAM, you will find it that we have for runway condition code 3, and then ICAO has in brackets the word the slippery wet. The issue is that well, unfortunately, there could be runways where the runway surface friction values are below the minimum friction level. And you may know that in that way may be slippery when wet. And in this case, we want, whenever we have such a NOTAM in force, whenever the runway is wet, instead of publishing information of runway condition code 5, they have to report runway condition code 3. And the other changes that we have included in the SNOTAM is, okay, apart from the two terms, we simplified the situational awareness section. So if you go to ICAO documentation, you will see there that you need to report for each taxiway and for each part of the apron separately. And we said, okay, this is going to be quite a long NOTAM string if we have a large aerodrome. So we decided to group them. And well, actually, we are going to notify ICAO about the changes we have done, and we will look for changes also in Annex 15 and in PANS-AIM. On the METR, we have changes also. For those who are familiar with METR, well, currently there is a runway surface condition information in the METR, but this will be removed when we start applying the GRF. And of course, there is the obligation of the pilot in command to report back when braking action encountered is not as good as reported. And it's very, very important at this point, because it's not only the aerodrome operator that does the assessment and provides the information to the pilot. It's the pilot is a feedback loop. This can be done either automatically, as mentioned in the previous presentation, where you can use the aircraft as a measuring device, or by the pilot based on his assessment, what was the deceleration of the aircraft, the lateral control of the aircraft. All these things are part of the assessment. And it's not only the pilot, but also the air traffic control. Don't underestimate their role. And they are, it's an important, they are very important in the chain of the information, in the transfer of the information, in the integrity of information, because they have to transfer the information from the aerodrome to the pilot, either through radio telephony or through ATIS. And this has to be done correctly. And of course, they need to be aware that whenever they receive an information from the pilot, they have to transmit this to the aerodrome immediately, because this information may trigger additional actions by the aerodrome operator. And the last thing is that we had changes to the ATC phraseologies. So in PAMS ATM, the phraseologies have been changed because we changed the way of reporting, and this has to be adjusted also in the European rules. On the air operation side, well, the pilots, before landing and actually before the top of descent, they have to conduct the landing distance assessment at the time of arrival. So they get the latest weather information and the latest information on runway surface, and they need to calculate what is the landing distance that they require, and they can apply some correction factors, which normally is 115% of the actual landing distance. This is their margin, but the runway condition code is used as an input to perform their landing calculations. And as far as I know, Airbus and Boeing, they have already prepared and they have made available this information to their customer airlines. And of course, it's in their regulations, what I've said before, that whenever they experienced a braking action which is not as good as it was reported to them, then they have to inform the air traffic services immediately. And the performance data either can be approved data, so they have to be in accordance with CS25, or supplementary data. So even if they don't have the data by the manufacturer, their regulation provides alternative ways to do it. And even if the supplementary data are not there, they can apply some generic factors. Now, the implementation. Well, in Europe, well, we had a big discussion in EU, and so we were planning for November 2020. So then we had the COVID-19, and we decided to postpone ICAO, put it in November 2021. But in Europe, following some discussions with the member states, we decided to go for the 12th of August 2021. And the reason behind is that during in summer, we do not have, we have, let's say, good weather conditions. There's no need to issue SNOTAMs. And we said, okay, it's better to transition the system in summer where we don't have so many, we don't have difficult weather conditions. So that was the idea behind. But in the meantime, we are trying to support our states to implement the GRF. We had some webinars last March. We give them guidelines about the training. And the other thing is that automation, automation is good, especially for aerodromes that they have very busy runways. We know that it's not easy to interrupt runway operations every 10-15 minutes to measure. So we support the development of these standards. I think something will come up in the coming months, but still needs to be reviewed. But we are supporting this. And COVID-19, it's the different level of experience and other airports down to the south, like in Greece or in Cyprus. So it's a difficult situation. First of all, to understand the concept, and if you tell airports that they have never issued a SNOTAM, that they have to do it now, they said, well, how shall I do it? We have these simple things that aerodromes do not understand. So it's a management of change. And we need to educate people, and we need to make sure that they understand and they will do things properly. And for the aircraft operators, well, it's training. We know that they have a lot of problems, a lot of issues, that they need to retrain their pilots because of the long periods of inactivity. So they have also to train them on the GRF. And the other thing is the availability of the performance data for all aircraft types. So for Boeing and Airbus, we are okay, but still we have other type of aircraft where we don't have the data yet. And well, how we are going to monitor this, first of all, through the standardization inspection reports. So whenever we visit states, it's going to be part of our inspection. Of course, we have our safety databases. So whenever we have an incident or an accident, then we need to go there and analyze this. And of course, at the end, we need to have review meetings with the states, the aerodrome operators, and the air operators to see how the applicability of the new method, how the application of the new method went for the previous winter, what we can improve, and how we can be better. And I think with this one, I am concluding my presentation. So if you have any questions, I'm very happy to answer. Thank you very much.
Thanks, Vasileios. Very interesting view from the regulator of what's been going on. Thank you. As I say, we'll do questions at the end. There's one more presentation. So I'd like to move on to introduce Will Sutherland from Halifax Stanfield. Will is currently the manager of airside services for Halifax International Airport Authority in Halifax, Nova Scotia, Canada. He helps ensure that aircraft surfaces and airside grounds are safe and the authority's vehicles and equipment are maintained in a steady state. Having worked in the airport sector since 2012, Will has a strong background in operations, safety, security, and regulatory affairs. His career began in aviation as a commercial pilot, as a flight instructor and manager of safety and quality of a flight training unit. Will's time in airports and the flying world has given him an invaluable perspective in pursuing best practices in procedures and service delivery in Halifax. Will, over to you. Thank you.
Well, thank you very much, and thank you for the invitation to be here. It's unexpected. It's a pleasure. And I hope I don't muddy the waters here with Canada's, or at least Halifax's implementation of GRF here. A little bit about Halifax Stanfield International Airport. I work for the Halifax International Airport Authority here in Halifax, Nova Scotia, Canada. We'll talk about where I am, where Canadian GRF is at. We did experience a 2 years worth of trials to get ready for GRF. We'll talk about those and then what opportunities we've discovered for learning along the way. So there's Europe on the right, there's Canada and the North America on the left, and Halifax is the lobster claw, as they call it there in the province of Nova Scotia, and that inside the yellow circle. So we are a coastal airport for all intents and purposes. We had a lot of influence from the sea. Our designator CYHZ, we have a couple of runways, quite long, 10,500 feet being the longest. That is a Cat 2 approach on the southwestern facing runway. We are relatively higher compared to the terrain around us. Halifax Airport is built upon a hill, which overlooks much of the region here. So you can see on a good day, 60, 70 kilometers in several directions around the airport. COVID has affected us all, obviously. So if you can see the diagram there at the bottom of the screen, we were over 4 million passengers, 4.3 million, I think it was in 2019. And boy, that shortchanged back down to levels not seen since the late 70s, as recent as a couple months ago. So cargo has stayed relatively steady, but we are suffering on the passenger side, as I'm sure many of you can sympathize with or relate to. A couple of points of note there. We do have Cat 2 approaches Cat 2 approach on runway 23, a Cat 1 on runway 14, and then the runway 05 and runway 32 approaches are each non-precision, and that's important when it comes to winter weather. We have a phenomenon here known as a nor'easter, and that is when winds are stronger to the northeast. The low pressure system rolls through here following the Gulf Stream. It dumps a lot of precipitation, a lot of wind on Halifax, and sometimes the runway selection, I'll say, the pilots have at their disposal, isn't always ideal, and they wrestle with the conditions that we have to present to them. So to manage those conditions, we have a fleet of equipment. It's not all listed here. We have 30 or 40 individual pieces of equipment. Our main fleet component is the VOMIS PSB 5500s. They're a high-speed plow sweeper broom combination, or plow sweeper blower combination. A couple of Beauchamp 9000s. We have various blowers of different sizes, one being high-speed that chases these VOMIS pieces of heavy equipment down the runway and getting rid of their windrows at speeds of 40, 50 kilometers an hour. Very efficient, very fast stuff. We have some big front-end loaders. We have a light plow machine and tractors to tow other attachments. We also have other vehicles on the runway at the same time, taking AMSCAR samples and whatnot. So the weather we're dealing with and throwing these pieces of heavy equipment at, again, Halifax being a coastal city, we've got the typical winter warm front. You get the snow first, then the ice pellets, then the freezing rain, then the rain, and then the cold front runs through and makes everything freeze solid. So it's definitely a challenge here in Halifax. We're always in that freeze-thaw cycle. And if we are looking to experiment with weather and how GRF works, we're a pretty good candidate. So we're happy to have been a part of it and exposed our staff to what's coming down the pipe for Canadian GRF. So like Vasileios was saying, but in the EASA world, they've made allowances, I'll say, or if you will, not departing from ICAO standard, but being flexible in how member states work within that. And Canada, our civil aviation authority, is Transport Canada. They've taken the same approach here in Canada, made something unique for Canada, at the same time being able to deliver something that matches the ICAO format. So Canada's geography and climate means we get a lot of weather, a lot of different types of weather. Our air operators here in Canada are used to dealing with it, if I can say that, and to limit the information they have, in some cases, may be detrimental to their confidence in using our airports. So we do experience multiple contaminants in any given storm. Like the examples there of the Halifax typical weather patterns that might happen over the period of a couple of days. It might happen in the period of a few hours, literally. So we do have to be careful how we report on services. We always have to be accurate, and sometimes that means giving a lot of information, and sometimes it's to our detriment, and sometimes it's to our benefit. We use something called the Canadian Runway Friction Index here in Canada. That is not a continual friction measurement equipment. That is a method of applying special braking procedures on the runway, performance being measured by a decelerometer, and then those performance values being communicated to aircraft. For the operators that have been in Canada for the last few decades, CRFI, as we call it, has been critical in decision making. And if nothing else, it certainly gives the airport operator like us a measurement of how well they're doing in clearing the services. So the typical response within ICAO and within GRF is that data is not to be published, and you'll see we're taking a bit of a sideways approach here in Canada to that. Canada's major airline operators have been using TALPA, the Takeoff and Landing Performance Assessment, internally. So they're taking our huge runway condition and contaminant reports and trying to make sense of it inside the cockpit or at the dispatch level, and turning it into condition codes that they can use for their flight crews in the air. And we're glad to finally be in the position where we can amalgamate that stuff. So 80% of the traffic in Canada is domestic or from the United States. We don't get a lot of European traffic or traffic from South America or the rest of the world, but it is there, and we do run into occasions where pilots need to know more about what's this CRFI business, or I believe I need a friction index of this to take off. Do we have that today? And I think the runway condition code presentation is going to be a big game changer for that. So we've because of our closeness to the U.S., we've adopted their TALPA model when it comes to how we incorporate the RCAM and that into our GRF principles in Canada. as Transport Canada would say, it's a GRF sports car with a big, powerful Talpa engine. So there we are. So the big differences you'll see here is that the RCAM that we use in Canada has been modified to include CRFI values. Those are the friction values we're sampling from those special braking stopping procedures on the runway in our downgrade criteria. And if you look at the United States' RCAM, they use mu values from a continual friction measuring equipment. Again, ours is a bit different, but we can supplement the RCAM and our runway condition codes and decision making with the CRFI value. We will report on 2 contaminants per third. It does make the text in the NOTAM a bit longer. The feedback I think Transport Canada has received from industry is that the air operators, as a majority, want that information, and traditionally we've done it, and we will continue to do that under Transport Canada's guidance. We will be publishing friction values from the CRFI reports we are getting. Again, air operators are, for the most part of the mindset, it is valuable to them. Perhaps not the large air carriers, but certainly things like smaller operators who don't benefit from reverse thrust or have different types of aircraft that they operate, that they relate better to CRFI than they would than not. It's there for them. However, it's published, as you'll see later, under non-GRF Talpa information in a separate section of the NOTAM. So it's there if they want it. For operators that don't want it, their regular NOTAM flow is not interrupted. So there's an example of the Canadian version of the RCAM. So you see on the left, you have your assessment criteria, which matches the ICAO version. And on the right, especially in the middle of the page in the middle column, there's your CRFI range. That's a Canadian Runway Friction Index range. Much like the mu values from the United States, you have values tied to braking performance measured on the runway by a vehicle and a decelerometer. And those values influence how we downgrade the runway, along with vehicle observations and observations by the person doing the AMSCAR reporting, and also the pilot braking action. So a typical flow would be, the initial assessment, we call it, the preliminary assessment. The person doing the AMSCAR would decide, well, the air is warm today and the ground is cold. I think I start seeing some frost out here. So the very first indication would be, hey, there's frost in my initial assessment under the assessment criteria. We've got a runway condition code of 5. So if there is frost, that allows us by regulation to do an assessment via CRFI. We can't do that on everything. Things like in the past, things like slush, wet snow, there was too great a risk of that data being contaminated, I'll say, not to mix terms. I should say that data not being valid because of the risk of hydroplaning, and wasn't always as accurate as it was assumed to be. But when there's dry conditions, for the most part, I'll call it dry, being frost out there, it's cold, there's frost, we can use a CRFI measurement system. So we do that. Our driver goes out and gets a CRFI of 0.32. So we reference the middle section here again, and he's now considering a downgrade to a condition code of 3 because that 0.32 falls within that range within CRFI. He hasn't observed any aircraft braking performance. He hasn't observed any slipping and sliding with his vehicle. But I think the operator of the aerodrome or my staff feel much better saying, hey, we've actually got an objective measurement now from something we're used to. Even though frost should be a 5, it's pretty slippery out here, guys, and it might be worse than that. We're going to call it a 3 based on our observations. Airplane lands. The Embraer landed, just got a braking action report of medium to poor at the midpoint. Great, just what we want to hear, even worse. So now we go out, do another runway assessment, and we downgrade it to a 2 because the aircraft are really the final arbiters of what this is going to be. So we'll take our best shot, our preliminary assessment, and then what we get for downgrade assessment after that, or downgrade criteria, we have to be honest with ourselves and put it right in the system. So I think the trickiest decisions are going to be when you're operating in that range of 3s and 2s, isn't it, for runway condition code? 6, 5, 4, everyone's pretty confident they can get in. You start talking about 2s and 1s and 0s, it becomes a lot more impactful for the air operators and the air drone operator or the airport operator to be very accurate and to stand firm if questioned. So we want to make sure we're giving the very best data we can. So there's an example of what a Canadian GRF NOTAM may look like. So what you have is COIHZ at the first indicating Halifax. We're talking about runway 23. We've got our condition codes coming up next with 5, 3, and 3. And they correlate with the 5 being 50%, eighth of an inch of dry snow, and 25% compact snow. And then you'll see, obviously, there's 2 contaminants listed there. Even though one is of lesser coverage than the other and has a graver impact on the runway condition coding, if they're all on equal terms, there's more dry snow there than there is compact snow. So dry snow takes the cake there and generates a condition code of 5. And then so on for the 3s, there's 2 contaminants and another 2 contaminants with a different scenario there for coverage. And then when you look down below, we have additional non-GRF TALPA info. So for those that don't need to see this, they've already read everything they need to go to the NOTAM, but beneath that, for other operators that are concerned, they can see that in the first third of the runway, 2, 3, they've got a temperature of -3 degrees and a pretty high curfew value of 4, and then a 0.32 and a 0.33, which is right down in the 3 range. So the science works on this particular bit. So we were lucky enough here in Halifax to be part of the trial that Transport Canada, our civil aviation authority, put on for getting ready for last year before COVID really took off. We hoped to have things rolling by November 5th of 2020 last year, but as the other participants here have said, that did not happen, and rightfully so. We were chosen with 14 other airports in 2020 to test our ability to work within the feedback or the guidance material rather that Transport Canada had offered us via what their take on the ICAO GRF, how it applies in Canada should be. We have very challenging conditions here on the east coast of Canada, for sure, and other parts of Canada as well. Paul has seen his share in Montreal, no doubt. The goal would be to not have the guidance material wrote in stone, but to, through collaboration with the airports and other industry groups, figure out what makes sense for the go live for changes to the guidance material, be it wording or detailed changes that only people like us can find out when we start using the system. So we had a really successful version of that. We were able to settle on many different phraseology changes and gave lots of advice, and it was successful. And the last it came to the delay of GRF into this year. So in 2021, for this winter that has just passed, thank goodness, Halifax participated in the second national trial. The documentation we had to work with today, the guidance material is now much more robust. It is more matured. We do have a couple of vendors that offer software solutions to make the reporting process easier for us. And then also our air navigation service provider, Nav Canada, for our ATS, has some cloud-based reporting systems which make it easy for us to input this data as well, which we did not have to experiment with last year. So at least not to this level. So things are really starting to come together. Our goal with this trial was to see, again, just how watertight or how airtight is this system. And we think we understand the guidance material. We understand it's probably not going to change that much, but be it if there's any glaring safety issues with the go forward plan, that was the idea for this year, was to flush that stuff out. So our observations over the last couple of years was, in Halifax at least, we deal with uniform runway conditions most of the time. And I think that was mirrored across Canada. And when I say uniform runway conditions, if the first third is a 5, the next couple thirds are probably going to be 5s as well. And that does change based on factors, be it weather or aircraft movements and aircraft type. Things like jet blast on areas, and literally the de-icing fluid rolling off the back of the wings as they take off, and how that affects certain friction on certain parts of the runway. In Canada, according to the trial results, 36% of the runways sampled generate different conditions between thirds. So that's a different runway condition code or a different set of contaminants. So for the most part, not 36 is a pretty big number, but for the most part, you're looking at a uniform runway condition. And that information getting out to pilots hopefully helps them feel confident that what we're reporting is accurate if it all comes up 555 or 333. It's not just an arbitrary check the box exercise. There's some serious thought that goes into each assessment. We found that when we are able to measure friction, remember we mentioned that we can't measure friction in every case with every contaminant. Certain contaminants we can. I believe it's dry snow, ice, compact snow, frost. I might be missing something here, but anytime there's a lot of water content in the contaminant, we are unable to measure friction. But when we can, so far the science suggests that the assessed value is right about 50% of the time. We do see downgrades in Halifax, at least based on our humidity, runway conditions beneath the dry snow that's falling. In dry snow, we're finding that we are getting slipperier results than not. It could be because the ground is not frozen yet. We get some cold snaps here. When I say a cold snap, I mean really cold weather that brings along some dry snow, and the ground isn't even frozen yet in the early parts of winter and through the thaw in the midwinter. So not sure what kind of science goes into that, but we are noticing that when we can measure friction, we are getting more often downgrades coming into play. Upgrades. From our perspective here at the Halifax airport, we're probably not going to be doing a lot of upgrades, and that's just for the fact that we don't want to be reporting on a runway surface and giving the wrong impression, because in Halifax, Ian, at the top of the mountain here, things can change very quickly, and it's not too often the weather stays in one state. I think there's a saying here in Nova Scotia that if you don't like the weather, just wait 5 minutes, it'll change. So furthermore, the runway upgrading process, we would like to stick to the science, that initial assessment when it comes to the downgrading and the upgrading. There's a little bit of hesitation to do that because of the volatility of our weather here. We don't want an aircraft to land on a runway which has gone south on us again, or has deteriorated again when we weren't looking. Even though the upgrade procedure is to continually monitor, we do that anyway, and we don't see us right now being able to do a whole lot of those things. The shift from traditional AMSCAR methods to the GRF demands a robust training program. So we found that our group of workers here, it's a varying age group. These folks have been doing this for a long time for the most part. They're a high performing group, not always dynamic because they are specialists. So to take from what they've been doing for a long time, for decades, sometimes, and then switch it on them here with GRF, you can imagine there's some controversy there. So to bring them to the table, to ensure that their input is recorded, it's absolutely essential that an airport like Halifax collaborates with the staff and build a training program that works for them, and supporting SOPs that work for them as well, because pretty high stakes game of reporting runway conditions, especially when it's new for everybody. So we did find that through the trial, and when generating procedures for GRF, we found a lot of opportunities to look at our other procedures and say, hey, well, we're putting a lot of focus on runway reporting here. We look at it for our traditional methods when we're not doing the trial. And we found that some things that we're not quality assured, we're not being audited to the best of our ability. Some gaps in our documentation was uncovered, so that was very useful as well. So our local air traffic service provider, NAV Canada, very interested in what we're doing with this stuff, and it's great to see that there's been training opportunities presented through ACI and other vehicles there that weren't there this time last year. It's apparent that some of the controllers really need to know, or feel like they need to know, because they don't know yet. So that's coming soon, and hopefully by August 12th, which is Canada's implementation date as well, we'll be all up to speed, and things like that I'm sure will help. Just wanted to flash up quickly a traditional AMSCAR versus a GRF AMSCAR. So you're a pilot, you've got this thing in your lap here. You've noticed if you're sharp, you've got one runway closed at the top of the no TAM, and then 1432, the only runway that I have open. Well, I'm coming in. You know, I've already on my way to Halifax. 05 close, okay, whatever. I'm taking runway 14. And conditions, whatever they may be, I'm taking the runway. Or they've done all their planning for runway 05. We've closed it 5 minutes before they were cleared to enter the terminal airspace, and now we've switched up on them, and someone has to make a decision if they're taking 14 or 32, and then maybe the winds are splitting. So not a lot of time to do calculations, not a lot of time to do a whole lot of pilot decision making other than a cut or dry. Do we go or do we not go? So this is where it gets a little bit insidious. If you look at the conditions, 60% wet snow, 40% wet snow over ice, if that's misinterpreted or something is missed, something's lost in translation, it can be very dangerous for an aircraft. And you mix that in with things like quarter and crosswinds, tailwinds that you're landing with, nighttime, precipitation, low visibility, the odds stack up pretty quickly against the aircraft to receive the correct inputs to make that aircraft land safely. So if you flip over to the GRF format from this, you know, someone on the ground is now working in the GRF format to say, yep, well, I don't know if you guys can see okay, there we go. We've said, yeah, there is 60% wet snow. That covers a lot of the runway. However, there's also 40% of wet snow over ice, thus the runway is a 0. Boom. No calculations needed. Both runways in Halifax now are not usable. 05 is closed for reasons, you know, not necessary, and now the runway that is in use that you just got switched to, that you have accepted, or the controllers are asking you for your decision on, you can say it's a 0. Yeah, well, we're going somewhere else, just like that. And you know, there's an example of one of the NOTAMs that would be generated as a result. You've got your 0, 0, 0. Doesn't matter what the conditions are at that point. I'm going somewhere else, or at least until the runway crews can improve the status. So that's the value we'll get at a GRF, everybody. So it doesn't come without its concerns for us. Some things for us to investigate between now and when the season really kicks off here for wintertime. We're trying to write policy as for how we respond to aircraft braking performance reports or braking action reports. Right now, we want to be proactive. So a braking action report of poor, we're out there, we're closing the surface, we're cleaning the surface, we are trying to bring it back up to snuff where it'll be a medium or a good. But what if an aircraft lands with a braking action of poor, and before we can get out there to do our thing, another one lands right behind him, maybe 1 minute, 2 minutes behind him, and they report good for type? How do we ensure that the data we're getting from the aircraft is I gotta be careful how I say this, but I'm a pilot, so I can kind of dance on this one a little bit, but the data isn't contaminated somehow, or it's been misrepresented. For an example, a couple of weeks ago, we had a weather event here, a late spring or a late winter weather event, early spring weather event. A 767-300 landed on runway 14, ILS approach, braking reported as nil. The aircraft stopped in 4,600 feet. So that's pretty good for a 767 reporting nil braking. So how would we respond to a situation like that? Is it nil in a section? Did they lose control for a moment? Because that's effectively what it is. You're losing control of the airplane in nil braking. Where was that? How widespread was it? Does it affect the whole runway, a third of the runway? Was it, you know, maybe when they reported nil braking, they actually meant to say, no, we don't have a braking report for you today, or something like that. It's hard to gauge that, and with training, with the implementation of GRF, that's going to get better. But what if we have aircraft landing with a tailwind, a quartering tailwind that doesn't receive the control inputs it normally would? Perhaps pilots apply the brakes late, and they really, you know, the aircraft is not receiving what it needs to get maximum braking, and the result is the pilot reporting it as a reduced braking performance because the aircraft didn't stop as they desired. So we have to figure out how that's best dealt with on our side. It's certainly going to mean greater attention for us in the summertime, especially for responding to when it rains outside. In the past here in Halifax, at least, if it did rain, we may not see an updated runway report. Now we certainly will have to, because it has an obvious effect on runway or on aircraft stopping performance. So we'll have to staff up accordingly for that, or change procedures accordingly. There's a worry, I think, amongst industry overall, that there's potential for airports to be too conservative, or potential for airports to be pressured into achieving a goal of a certain runway condition code, so their air operators there that day can operate, that the flight waiting to go with the hundreds of people on board can get out for Christmas Eve. That, believe it or not, that does weigh on the people on the ground to a certain extent. Some folks are better at distancing themselves from that than others, but it's a real human factor that we have to identify in training, and being sure that we can report what we see as accurate each time, and that the air operators here in Halifax understand that we are doing the best we can do. We also know the air operators are generating their own procedures around what GRF is going to be, so they're perhaps deciding, hey, if you have a 4 or a 3, you can land. If you have a 2, you don't land. But in the RCAM, dry snow over 1/8 of an inch with no upper limit is a condition code of 3. But it's up to the airport authority to decide, give it your best shot, and if you think the runway is dangerous, make sure you downgrade it to an appropriate level. So we'll be not wrestling with that, but trying to better understand what the expectations are from industry on what the aircraft can land in. One SOP I've seen suggests the aircraft can land in snow that is inches deep. So it's something to keep an eye on. Some of our staff have identified that they'd like to see physical markers alongside the runway in the fields. They can quickly identify where they are on the runway when they are assessing the runway. They're no longer assessing runway in full length, they're assessing it in thirds. So are there easy identifiers they can put around the runway edges to say, okay, I'm now passing, whatever third section of the runway I'm in. Some parts of the runway, it's easy because you have things like lit taxiways that you can reference yourself with, landmarks, easy landmarks either side of you can see. Some sections of the airport are not so easy. So a physical identifier, especially when the chips are down and you have 100-foot visibility or less, or whatever it may be, is desired. Now, we talked about friction not being able to be measured previously on things like wet snow or things when there's a higher water content. The regulations have opened up in Canada to permit that under certain conditions. So when the wet snow basically is not wet enough to allow water to drain out of it, when it's nice packy snowball type snow, as we say here in Canada, wet curfew readings or friction measurement on wet snow may be possible. And how will that correlate with the RCAM? How will that affect the frequency of downgrades is in question. So this is not me being pessimistic on this last slide. This is just these are the questions that are floating around here now. I think the addition of GRF is going to do so many things for aviation safety. Unfortunately, here in Halifax, we have experienced the risk and threat of runway overrun and people being injured. There's occurrences which may have been preventable through more situational awareness, which GRF could provide elements of. So we're looking forward to it, and we're confident that whatever the outcome, will be safer than we are today when GRF does roll out. So I think that's it for me. I don't know if I've gone over time or not. I haven't looked at the clock. I promised myself I would, so I'm really sorry, but I just want to say thank you again, and we'll turn it back to you. Thank you.
Okay, thanks, Will. Yeah, a very interesting perspective from your experience. So that wraps up the presentations for today. So I've got a few questions now to run through that have come in and occur to various people from the sessions that we've heard. So I think we've got about 10 minutes left, so perhaps brief answers I would request. I'll start with Paul, if I may. Paul, I think you mentioned artificial intelligence and AI being of interest in the future. The NavBlue system was mentioned that gets Airbus friction aircraft braking performance actually experienced by the landing aircraft available back to the airport. Do you think that might be used in some way in the future? Is that something that might feed its way into this GRF, do you think?
Yeah, thanks, Ian. It's a good question. And to keep it brief, I think what we have now is a baseline. We have the GRF, which will be the human observer methodology to start with, but we have a baseline that I think industry will start to use, and I think Vasileios alluded to it. Will has talked about it a little bit as well. I think everyone has. I think eventually industry will develop tools to work with that baseline and provide an improvement to the GRF. So I think we start with the stick shift car, and we will move towards the Tesla self-driving in the future. So we have a very good baseline, and I think we will start to work with industry to develop other tools to help.
Yeah, okay, that's great. Thanks, Paul. Daniel, there was a few questions that came up from your Snap product. I wonder, is the system able to make reports available from other parts of the airfield, like rapid exit taxiways or access taxiways, or maybe taxiways in general? Is that possible to report some of that through the system, or is it primarily the runway? And I think you're muted, Daniel. No. Okay. Well, perhaps I'll let Daniel play with the settings or through the system. I'll move on to perhaps ask Vasileios a question, if I may. Vasileios, EASA has been the, I think I'm correct to say, the only formal rulemaking body that has put GRF into, if you like, into the law, if I can use that term loosely. Have you? I think in the FAA, it's a guidance circular. Do you have any feedback or comments on that aspect yet?
Well, yes, indeed, we were, I think, the first region where we had the GRF in the at regulation level. But as I said, well, it was not an easy. You know, you were with us when we were doing this exercise. It was not an easy one because you need to keep the basics well steady, so people cannot deviate, and give also some flexibility, because the rules need to work for every region in Europe. And so still we don't have, I can respond to this question, I think, after the first winter, when we apply this. We are optimistic. Of course, we are expecting some issues, and but here we are to work. The approval process, it was not very difficult, because at EU we were determined to have the rules ready on time. So, but I think after the next winter we will be able to say much more things.
Yeah, okay. Yeah, fair enough. Thanks, Vasileios. Daniel, are you back with us now? Do you want me to repeat the question, Daniel, that I had for you?
Ja. Lite. Bara brusen.
Doesn't sound like that's working, so maybe I'll go to Will and we'll try Daniel one more time. Will, I heard about your description of Curfy and the Canadian system, but I wonder if I could ask a question about if you have any feedback on how the Canadian airlines experienced moving into Talpa, sort of flying into the States, if there's any implementation lessons that might be useful for us with the ICAO deadline coming up. Was there any experience from there you could share?
I can't speak for them. Unfortunately, as late as, I think it was 2016, we were talking about air operators already implementing that internally. And it kind of went seamlessly and quietly. So I will say they've been very vocal about things like Curfy not being published as part of the NOTAM. They did not want that included at all. And, you know, the Transport Canada seen fit to appeal to the wishes of all the operators in Canada, I guess, and hopefully we've made a good middle ground there. But no drastic comments on that from how they experienced it, other than they took it internally and made it their own. So it must be working. Okay,
great. Thank you, Will. So, Daniel, just to recap, the question was if the SNAP system could also cover other parts of the airfield, like maybe the rapid exit taxiways, rapid exit access taxiways, etc.?
The short answer is yes. I only presented a brief overview of the system, but we have taxiways and aprons as part of the reporting section.
Okay, that's great. Thank you. And perhaps one more for you, if I may. There's been comment that particularly at an airport with many runways, the length of the code, the SNOTAM or the message on ATIS will be quite lengthy. Will there be any likelihood of the SNAP system getting the information perhaps directly into the system, or maybe directly onto digital ATIS at some point?
The short answer there is yes as well. We're working on a direct link to Eurocontrol at this moment. So it is an open system where we can feed in the system digitally to another open end interface. So yes.
Okay. Oh, that's great. Okay. Well, thanks very much. I think we're done. We're nearly out of time. That's run pretty well. That's it for today. The next session is session 2 of the Winter Ops series. We'll be looking at aircraft de-icing, which is next Wednesday at the same time as you join this one, 2:15 BST. And if you'd like to register, there's a link in the comments. Before you go, I'd like to thank Paul, Daniel, Vasileios, and Will for joining us, and a big thank you to the session sponsor, SYS-ASFT, and also a thank you to you as all the delegates who've joined. I'm just being reminded there was the poll complete, so perhaps a concluding remark that asked, how confident are you that you'll be GRF compliant by the deadline? If I add up the figures, 81% are saying they are probably or definitely likely, and 19% are saying unlikely to be ready. So maybe there's still a little more work to do between now and the November deadline for ICAO and August for the EASA and Canadian rules. So that's it, everybody. Thank you very much. Thanks and goodbye.
Thank you very much.
Thank you.
Thank you, everyone.
Thank you. Bye-bye.
Bye. Bye.